Hello everyone, welcome back to another session by K21 Academy, and today our expert will be discussing about introduction to AKS architecture, in which we'll be giving you a complete holistic overview of the Azure Kubernetes Service architecture. So watch the video till the end.
Hey there, so welcome back. And in this lesson, we are going to look at Kubernetes on cloud, and specifically, we are going to look at Kubernetes architecture and as well as AKS architecture and what this Kubernetes means. So in Kubernetes, there's a master node, which basically is also called as the control plane that controls all the worker nodes. So there is a concept of master node, and there's also concept of worker node. And worker nodes are multiple hosts on which your containers run, and on those containers, there's something called as pods. We'll explain that in a minute about what that pod are. And on these pods, you have your applications running. So applications deployed on pods, and pod is collection of one or more containers. These containers or these pods run on a worker node, and multiple pods can run on a worker node. And like that, you have multiple worker nodes, and these multiple worker nodes are managed by a master node. And you can, for high availability, you can also have a multiple master nodes. So this is the typical Kubernetes architecture. Now in Azure Kubernetes, the master node is managed by Azure, and you provision the master node or you provision the worker node, and with that you will get a master node. But that master node is fully managed by Azure, and also the master node is absolutely free on Azure. So this is in a nutshell about Kubernetes. So before we go further into and look at Kubernetes architecture, let's look at Kubernetes on cloud. So the Kubernetes can be deployed on premise, but it can also be deployed on the cloud. And because of the adoption of Kubernetes in on-premise world, pretty much every cloud company can think of are implementing this Kubernetes on the cloud. So as we are discussing in this class, this is for AKS, which is Azure Kubernetes Service from Microsoft. So Microsoft's Azure Cloud is Azure Kubernetes Service. Then similar to that, AWS has their Kubernetes, which is called as Elastic Kubernetes Service, EKS. Similarly from Google, GKE, Google Cloud Platform, or Google Kubernetes Engine. Then from Oracle, they have Oracle Kubernetes Engine, and from Digital Ocean Kubernetes Service. So like each of them have their implementations, same Kubernetes, but in their own implementation way. Slight things are different and slightly because of the cloud. They have a different networking or storage options. Similar to that, the management or the master node might be free or some charges depending on which cloud vendor you're talking about. So in AKS, we are going to focus on Microsoft Azure Kubernetes in this case here today. So container services on Microsoft Azure, we have already discussed container instances in one of the previous lessons, where container instance is a platform as a service offering that allow you to upload your containers and then you run these containers in the cloud or in a Microsoft Azure cloud. Similarly, Azure Kubernetes Service is a container orchestration service for managing the large number of containers. So the container service, when you create, it will automatically create when you create a Kubernetes service, it will automatically create a container runtime inside that. Now, this is the overall Kubernetes service with CI/CD, end-to-end Kubernetes service, or all the options with bells and whistles, I say, with Kubernetes. So what you see here in these dotted line, this is the actual Azure Kubernetes service in production environment that will have multiple master nodes managed by Azure and multiple worker node. Depending on how many worker nodes you define, it'll create that. In the labs, we are going to see that in subsequent lessons. Then, in order to manage this Azure Kubernetes, you can also configure or have Azure Monitor service, which is monitoring and giving any notification or all monitoring setup that you can do. This Azure Monitor is a separate service. Now, on Azure Container or Kubernetes service, you run your applications, and that applications can come via the Azure pipeline, which is CI/CD tool, continuous integration, continuous deployment tool, that something similar to Jenkins in CI/CD pipeline. Similar to that, Microsoft Azure has Azure pipeline through which you can deploy your applications that can run on top of the Kubernetes cluster. Or these Kubernetes Azure Kubernetes production environment can get the details or can spin off the containers from the images that are stored in Microsoft Azure Cloud Registry or Container Registry. So this will have all the images that your production needs to run. Now, there's a concept of Helm and Helm chart we have not looked at, but we are going to add this as a bonus in our Certified Kubernetes Administrator CKAD or CKA or Certified Kubernetes Application Developer Program. So Helm is a package manager that deploys packages or the applications on top of Kubernetes service. So you can have these deployment are run as a Helm chart, and these Helm charts can be stored or deployed using the Azure pipeline to the Azure Kubernetes, or this Helm chart via the Azure Container Registry into the cluster production. These are the other, you can also basically in a nutshell implement or incorporate Helm chart onto your Azure Kubernetes. Now, as I said earlier, the container images or Docker hub or Docker container image will be stored in Dockers. These Docker images can also be configured or can be pulled by the Azure Container Registry to deploy on the production Kubernetes, or through the pipeline, you can pull these container images and deploy on production environment. Now, if you go on further left, your source code, so whatever developers develop these images or your applications or the YAML file, which we'll see what is YAML file in subsequent lessons, but the code through which you deploy your Kubernetes, that can be put into the source control like Git. And this is where the top layer are spaces, your workspaces, where developers are developing their application and testers are testing that. This is a send environment or sandbox environment for Kubernetes. So this is the entire Kubernetes service end to end. You have the workspace, you have the source control, sending the data or the source control check-in, the pipeline, deploying code into production environment, and the monitoring the Azure Kubernetes service. So that's in a nutshell about Azure Kubernetes Service. Now, if you go further look at architecture, as I said, there's a worker node, and on that worker node, you run container runtime. And Docker is just one representation here. Now you can run any container runtime with Kubernetes. You just need to change configuration. By default, it's right now container D, and by the time you might be listening, there might be something else as well. The default container runtime that gets deployed with Kubernetes architecture. So assume instead of Docker, you might have another runtime, container runtime. And then like that, you have multiple worker nodes on which your container runtime. Then you also have a master node, and in this master node, assume this is a brain of your Kubernetes cluster. And that master node applications or master node services can also run its own container. And master node has a component like API server. This is the brain. Basically, all the requests that you connect or you issue to the cluster, they hit the API server. Now, controller manager are different type of controls or controllers. In order to manage those controllers, you have control manager. Scheduler is for your jobs or any task that you assign to Kubernetes cluster. They are being assigned to scheduler, and scheduler in turn will then run those onto the appropriate worker nodes. etcd that you see, this is the configuration repository, or this is the distributed database that stores all the configuration, like how many worker nodes are there, what application is running where, how many replicas needs to be run. Any configuration that you have, any persistent store will be in etcd. And then in each of these worker nodes, you will have kubelet, which is kind of an agent that's basically interact with API server. Then you have a C advisor, which will have which will keep the metrics or in terms of how much memory process are being used in this node. So that's being controlled and given or picked up by a C advisor and then given to kubelet. Kube proxy is basically for the networking. So any network or clients they connect onto this applications running on those host, that will be for kube proxy. Now there is a CNI, which is container network interface plugin that connects these different worker nodes to talk to each other. Then as an administrator or a developer, you connect and interact with API server, and that connection or communication will be through API server via the command called kubectl, KUBECTL, or in AKS, which will be AKS CTL. We'll cover that in future lessons as well. So kubectl or API server. Then API server will store all the configuration into etcd as we discussed. So API server will talk to etcd. API server will also talk to scheduler for any jobs or any tasks that being given that happened via the scheduler. Now that API server will then via the scheduler interact to the kubelet. So kubelet will be the agent. So if the master node needs to talk to any worker node, it will be done via the kubelet. Now, in kubelet, you deploy, or in containers, you deploy something called as pod, and pod is the smallest deployable unit in a Kubernetes on which you run your application. So there'll be pod. And then any configuration or response back will be sent via the OPA server and stored in that etcd. Now you also have a controller manager, which will basically manage all the controllers. So there are different type of controllers will in the Kubernetes, like deployment manager or replicas or horizontal pod auto scaling will see the auto scale controllers and so on. So that will be managed by the controllers. Now these controllers, for example, you can say, I want to deploy the application on pod. The controller will then, via the API server, will check on the kubelet what is the right node to deploy that pod, and that pods will be deployed. And this worker node will have multiple pods. Now, the end users or customers will connect to the pods or the application running on the pod through something called as service via the kube proxy. So kube proxy is a network interface layer for the connections. So just to do a nutshell, a recap, the API server, which basically is the server that configures and validates the data for API objects like pod services, and it's the front end for the control plane. So you'll be firing the commands and they will be coming to the server or master node, that all the APIs, which is application programming interface, that APIs will be receiving by the API server and then will create or spin off services, other services. Scheduler that you see, this is the one component that decides on the cluster what workload to run where, and these will be based on the conditions based on the CPU memory available on these pods. And you might also define conditions saying that two pods must always run together, or these two pods should never run together. Based on that, scheduler will decide. etcd, as I said, will store all the cluster related data, and the cluster controllers are the daemon or the processes that embeds the core control loop that regulates system via the routine task. And what that mean by regulates or control loop regulates the system via the routine task is, let's suppose you say, I want to run my Kubernetes worker node in 3 nodes, and at any given point in time, on the 9 replicas of that pod should run. So the controller will then constantly check and say, hey, 9 replicas are running or 9 containers are running or not. And if the minute one container fails, the controller will then go and check and start that machine or that particular process or that particular container. It will start that container. And hence these controllers are control loop, basically constant checking and making sure that the configuration actual versus the desired state versus actual state always matches. Then from the worker node, as we said, you have kubelets basically acting as the agent for performing various tasks like mounting the volume, running the containers, assigning the pod to a node, and so on. Kube proxy, basically the connection forwarding client will get a request on kube proxy and forward it to the appropriate pods. Docker, or the container run engine on which your workers the applications run as a pod. CAdvisor basically provides the metrics of how much is being used, how much is available for these containers. So this is in a nutshell about architecture. Now there's one more component, which is Cloud Control Manager or Cloud Controller Manager in a managed Kubernetes or on cloud. Basically, this Cloud Controller Manager will provide all the necessary underlying cloud resources like storage, networking. So Azure has 2 types of storage. We'll see that in subsequent lesson. So files, or there are multiple types of storage, but out of which 2 types, which is main, is disk and files that being used, or networking, what all different networking options are available. So if you look at the architecture we looked at earlier, the master node or also called as control plane, which has an API server connecting or storing all the configuration in etcd. Kube Controller Manager for managing the entire system so that my desired state matches with the actual state. And then Kube Scheduler to schedule any jobs or works. The worker node that are nothing but a virtual machine behind the scene running container runtime. And then you have a kubelet, which is agent running on each of these nodes, and kube proxy for client request. Additional component, which is this in cloud managed systems or cloud Kubernetes on cloud like AKS, is your cloud controller manager that provides underlying cloud resources like virtual machines, storage, networking, and so on. So this is in a nutshell about Kubernetes as well as Azure Kubernetes. And you can create Azure Kubernetes Service through multiple ways. You can create using Azure CLI or command line interface for Azure or Azure PowerShell or through using Azure Portal or through using ARM templates, which is Azure Resource Manager template. And once you have developed or created the cluster, then you can connect to this cluster using kubectl or AKS CTL or deploy the applications on this Kubernetes cluster and then test the application. That's in a typical workflow going to be. So just to do a recap on AKS architecture, each master node is managed by, or there will be multiple replicas of master node. You don't have visibility of that master node in AKS. These are managed by Azure for you. This is where you have worker node or one where you have access, and each individual node will be a virtual machine on which you're running one or more pods. Each virtual machine or each your worker node will have a kubelet, as we saw, or a kube proxy, and kube proxy will interface with your Azure virtual network. Container runtime will store its data into either Azure disks or files, and this is your container runtime. So I hope that makes now it becomes clear. And before we wrap up this lesson, let's quickly look at the pods as well. So the pods is, as I said, is the smallest deployable unit in Kubernetes on which your application runs. And you can have multiple pods in running inside one worker node. So you can have 1, 2, 10, depending on how many, what is your resource or how much memory and CPU you have in that host and how much each application needs on CPU and memory needs. Based on that, you can define how many pods you want to run. So this is a node on which you have container runtime, kubelet, and then you define pod. And pod is nothing but a container running inside a pod, and you can have one container or you can have multiple containers. So you have in this pod, you have two containers. Now, typically you will have one-to-one relationship between container and a pod. So one container per pod. In certain exceptional scenarios, you might need two containers in a pod. And if you're part of our Certified Kubernetes Application Developer Program, CKAD will create a container with multiple or we'll create a pod with multiple containers. So we call it design patterns related to the multi-container pods. We'll look at that as well in that. Now, in pods or any deployment configuration you deploy in Kubernetes, you do it via YAML file. And this is an example of YAML file, which is you have, again, we'll go a little bit later in this YAML file, or maybe when we do the lab, when we're deploying the application, we might show you or explain you the YAML file. So when you're deploying the pod, I'm saying it's a kind pod. If you're deploying a network, you will say kind network. If you're deploying a storage, you will say persistent volume, kind persistent volume. This is built on top of API version 1. And this is metadata, which means it's telling about this pod, what is the name of the pod, any label you want to apply. And label has a direct relationship with a service, which will cover that and when we look at networking. So how does a label plays an important role in forwarding requests to the pod? So label, will cover that in a little bit later. But my spec is that it's a container. The container name is a web container, and it's running from an image called Nginx, which is nothing but a web server, and it's listening on port number 80 on protocol TCP. So I'm deploying this pod on a Kubernetes cluster. So I hope that makes sense, or not fully, but this is a nutshell about Kubernetes.
So guys, this was a clip taken from our step-by-step comprehensive program that has 16 modules, 60 plus lessons, 35 plus hands-on labs, CV and exam preparation, and the most important, on job support. So this comprehensive program is specially curated for you so that you can be from beginners to a master, and you can master every skill set that has been required here. And if you're somebody who would want to start off their career in the domain, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paid jobs. And don't you worry, this interactive session will help you in gaining the understanding of why learn containers and Kubernetes, what is Docker container architecture. We'll be discussing about pod with highly available and scalable applications on Kubernetes. We'll be having demo so that you can perform really, really well. And now if I'm talking about that, what special do we offer? We have the comprehensive learning path for Docker and certified Kubernetes administrator course. So in week 1, we'll be talking about microservices and Docker. Week 2 is about Docker, networking, storage, and app stack. Week 3 is about Kubernetes architecture and installation. In week 4, we discuss about security, troubleshooting, and high availability. Week 5 is about networking, that includes all the networking policies, securities, contexts, and whatnot. And one thing that I have to mention here is that with every session, we have labs so that you can practice whatever is being discussed in the class, and this give you a knack over everybody because you will have the practical knowledge. Coming to week 6, we are talking about deploying of daemon processes and whatnot. Week 7 is about application stack. Week 8, we talk about advanced networking, of course, followed by some different laboratory sessions. And in week 9th and 10th, we are completely focusing on your certification preparation. That includes project work. Then we have certification practice part 1 and certification practice part 2 as well. And in week 11th and 12th, this week is completely dedicated for your CV preparation and your project work, because project work is something that is going to help you with all your exams and of course interviews as well. And now talking about the hands-on labs, and as you can see on the screen, we have almost every topic covered. So with every topic, you'll have a fine-grained understanding of whatever topics we are covering, and each topic you can have a practical knowledge that is going to help you in your examination and of course in your jobs. We also have sample exam papers in PDF format. And here you can definitely see on the screen that what kind of questions we have, and these questions are going to make you prepared for your exam and your interviews. So if you really want to have a basic, and if you really want to see what all we're going to cover, then we have this free class where we'll be talking about why learn Docker and Kubernetes and Docker containers architecture, image and containers and whatnot. So if you want to register for this free class, then just have to log on to k21academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now, select an event date, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface where you just have to save this link on the extreme right, add it to your calendars, and I will see you in the free class. Till then, keep learning.